Welcome to my channel VTU Physics. In this video we are going to cover the electrical conductivity in solid model number 4, and this video concentrated on 21st PHY 12/22 syllabus scheme. So in this video we are going to cover the topic called quantum free electron theory. Before we begin with topics, I would like to request you to subscribe to my channel, as I see more than 70% of my audience is still not subscribed to my channel. I request you to please subscribe to my channel, share with your friends, and don't forget to press the bell icon so that whenever I upload a video you will get a notification. With this, let's start the intro and then begin the concept. Thank you. Welcome to VTU Physics. In this video, we will cover the topic called quantum free electron theory, model number 4. Before we begin with the concept, I would like to request you to understand the syllabus. So, syllabus nalli bandbittu assumptions ide, density of states ide, Fermi energy anta ide, Fermi factor and its temperature dependency, Fermi direct statistics, expression for electrical conductivity, and last but not the least, merits of quantum free electron theory. So ಈ ಸಿಲೆಬಸ್ ನೊಳಗಡೆ ಸ್ಟ್ರೇಟ್ ಅವೇ 8 to 10 ಮಾರ್ಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಬಂದ್ಬಿಟ್ಟು ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕಂಡಕ್ಟಿವಿಟಿ ಡಿರೈವೇಷನ್ ಇದೆ. ಆಫ್ಟರ್ ದ್ಯಾಟ್ ಯು ಕ್ಯಾನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ 4 to 6 ಮಾರ್ಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಲೈಕ್ ರೈಟ್ ದಿ ಅಸಂಪ್ಷನ್ಸ್ ಆಫ್ ಕ್ವಾಂಟಮ್ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಥಿಯರಿ ಆರ್ ಫರ್ಮಿ ಫ್ಯಾಕ್ಟರ್ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಟೆಂಪರೇಚರ್ ಡಿಪೆಂಡೆನ್ಸಿ ಆ್ಯಂಡ್ merits of quantum free electron theory. These are the 3 topics you can expect for 6 to 4 marks. After that, 2 marks definition like density of states, Fermi energy, Fermi factor and Fermi direct statistics. These are the 2 marks concept. That's it. Now, before we begin with the main concept, we need to understand who proposed this the concept. Sommerfeld in 1928. How he proposed? By using these 2 gentlemen idea. One is Max Planck and another one is Pauli. So Max Planck, who proposed the quantum mechanics, and Pauli's, who gave how that electron is going to arrange itself in a various energy levels. By combining these 2 gentlemen idea, he proposed quantum free electron theory. So let's begin to see assumptions of quantum free electron theory. First one, the energy value of conduction electrons are quantized as various allowed energy level. So conduction electrons energy is quantized and which is distributed in various energy level, as you can see in this diagram. That is the first assumption. So second one is the distributions of electrons in these allowed energy levels takes place as per Pauli's exclusion principle. So that means these are the electrons which are going to occupy as per Pauli's exclusion principle. So as per Pauli's exclusion principle prakara andre, one electron and another electron, one electron must have up spin and another electron must have down spin. These are the 2 electron. There are 2 different electron which can occupy in one energy state. That is the first criteria. And second one is, if these 2 electron has one energy, okay, and this energy state must have another energy. So take it as 1 and 2. So if we going to compare these 2 electrons, these 2 energy must be equal. That means these 2 electron must have that much energy to stay in this state. Then only can these electrons are going to settle in that energy state. Otherwise, If these two electron has more energy, then it will go to higher state energy level. If these two electrons have less energy, then these two electron will try to occupy lower energy level state. This will decided by Pauli's exclusion principle. In module number 2, modern physics and quantum mechanics, we got one equation which is eigenfunction and eigenvalues, right? We have this equation n square h square by 8 m a square. A square is the width of the 1D box and n square is the number of energy level and h square is the Planck's constant, m is the mass of the electron, right? So this is the equation which we derived in module number 2. So ಅಲ್ಲಿ ನಮಗೆ ಬಂದಿರುವಂತ energy value for a ground state is 2.35 electron volt. Remember? So ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದೀವಿ, ಇಷ್ಟು energy, for example these are the ground state energy, ground state ನಲ್ಲಿರುವಂತ electrons. So ಇಷ್ಟು ಎನರ್ಜಿ ಈ ಎರಡು ಎಲೆಕ್ಟ್ರಾನಿಗೆ ಇದ್ದರೆ ಮಾತ್ರ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ನಲ್ಲಿ ಇರಲಿಕ್ಕೆ ಸಾಧ್ಯ, ಅದರ್ವೈಸ್ it is not possible to occupy this energy state by these two electrons. This is what Pauli's exclusion principle explain. So let us see third assumption. The third assumption says free electrons travel in a constant potential inside the metal but confined their state within the metal. That means ಯಾವುದೇ electron can travel inside the metal with constant potential. So constant potential ಯಾವಾಗ ಸಾಧ್ಯ? Only when there is absence of external force. So ಯಾವುದೇ ರೀತಿ external energy supply ಮಾಡದೇ ಇದ್ದ ಪಕ್ಷದಲ್ಲಿ then only electron can travel with a constant potential, and that too they will stay confined in the metal. They will not come out from the metal. That is the third assumption. And fourth one is the attractive force between free electron, the attractive force between free electron and lattice ions, and repulsive force between electrons themselves are ignored. That means free electrons has negative charge, lattice ions have positive charge. Due to this reason there will be an attractive force, and there will be a repulsive force when electron which has negative charge, another electron which has negative charge, these two electrons will get repulsive force. As we already know that like charges are attract to each other, like charges are repulsive, unlike charges are attractive. But in the case of quantum free electron theory, which we are going to ignore as per quantum free electron theory. So let us see the next concept, starting with density of states. As I said, only 2 marks definition, which covers definition and one equation. So what is the definition of density of states? It is the number of allowed energy levels per unit energy interval in the volume valence band associated with material of unit volume is known as density of states. To understand in better way, let us try to draw the diagram. As you can see, these are the various energy level, right? And these various energy level contain some electron which is occupied by some energy levels. So we'll divide it into 2 parts. Some energy levels are occupied, which we call it as valence band. Some energy levels are not occupied with single electron, or we can say empty states, which we call it as conduction band. And these 2 bands are separated by some energy gap, which we call it as Eg, or energy gap. As you can see, G of E into dE is equals to 8 under root 2 into pi m by m raised to 3 by 2 divided by h cube into e raised to 1 by 2 into d. This is the equation for density of states. Usually in the previous syllabus we have a derivation for this equation, but for the latest syllabus this equation is not for derivation. Only if he asks you to write down the definition, in that case you need to write this equation. This is about density of states, where it says the valence band. This is the valence band, where there is a number of allowed energy level as per unit in energy interval in the valence band associated with the material unit volume is known as density of states. So let us start with Fermi energy. Fermi energy define the energy of the highest occupied level, the energy of the highest occupied level at absolute temperature. What is that? 0 degree Kelvin is called as Fermi energy, and the energy level is called Fermi level. That means, let us try to understand with the help of diagram. So this at temperature 0 degree Kelvin, that means minus 273 Celsius. That means there is no thermal or electrical energy, external energy is there to supply for electron. In that time, how much electron is going to occupy at what level? For example, in this diagram, this is the Fermi energy level. That means to occupy this highest energy level at 0 degree Kelvin, this electron must have that much energy, and this energy is known as Fermi energy. Okay, so Fermi energy ಅಂದ್ರೆ ಏನು? at 0 degree Kelvin ನಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಎನರ್ಜಿ ಇಲ್ಲದೆ ಇರೋ ಪಕ್ಷದಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಹೈಯೆಸ್ಟ್ ಅಕ್ಯುಪೈಡ್ ಲೆವೆಲ್ ಅಕ್ಯುಪೈ ಮಾಡಬೇಕಾದ್ರೆ ಎಷ್ಟು ಎನರ್ಜಿ ಬೇಕಾಗುತ್ತೆ, ಆ ಎನರ್ಜಿಗೆ ನಾವೇನಂತ ಕರಿತೇವೆ? ಫರ್ಮಿ ಎನರ್ಜಿ ಅಂತ ಕರಿತೇವೆ. ದ ಲೆವೆಲ್ ಅಕ್ವೈರ್ಡ್, ಸೊ ಎಷ್ಟು ಲೆವೆಲ್ ಕವರ್ ಆಗ್ತಾ ಇದೆ ಅದಕ್ಕೆ ನಾವು ಫರ್ಮಿ ಎನರ್ಜಿ ಲೆವೆಲ್ ಅಂತ ಕರಿತೇವೆ. ದಿಸ್ ಈಸ್ ಅಬೌಟ್ ಫರ್ಮಿ ಎನರ್ಜಿ. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ the Fermi factor. So Fermi factor is the distribution function. Fermi factor is the distribution function which gives the probability of occupation of the given energy state for a material in thermal equilibrium in terms of Fermi energy, Boltzmann constant and temperature and absolute temperature. So let us see the what kind of function is that. It is the Fermi factor is the function, distribution function, where with the help of Boltzmann constant, absolute temperature and Fermi energy we are going to get the probability of occupation of electrons in the energy level. This is the equation where we are going to get the probability of occupation of a given energy state which is acquired by electron. So let us understand the Fermi distribution function at various temperature. For that, let us draw the graph, and before that, as I said, this is the equation which we call it as Fermi factor equation. So let us draw where x-axis has energy and this one is the Fermi energy level, and in y-axis we have function of or Fermi factor, function of energy or Fermi factor. So draw the level here. These are the electrons which is occupied by some energy level, and this energy level or this energy level we call it as Fermi energy level. The energy required to occupy the highest energy level, that energy we call it as Fermi energy. Okay, so here let us see three cases. In the first case, probability of occupation, energy is smaller than Fermi energy. energy is smaller than Fermi energy. That means below the Fermi energy, there is an energy. For example, to understand this, we'll say Fermi energy will become 9 electron volt and energy will become 3 electron volt. That means below the Fermi energy level. At temperature T is equals to 0, when there is a temperature T is equals to 0, then if we substitute these two values and this one here in this equation, what is the result? So as we can see, E raised to 3 minus 9, in that case the result of this is 3 raised to minus 6. That means E raised to minus 6 divided by 0. This means E raised to minus infinity. So due to this reason, E raised to minus infinity is nothing but 0. So as we can see, we solved this equation and we got f of E is equals to 1. F of E is equals to 1 in the first case. So that's why we draw the line, this line, and because we are at below Fermi energy level, so there will be a number of electrons are there. Now let us see the second case. So in this case, the energy is more than Fermi energy. That means the Fermi energy will be taken as 3 electron volt and the energy will be taken as 9 electron volt. That means the Fermi energy level is 3.3 electron volt and the energy is more than this. That means we are at here, we are at above the Fermi energy level. That means there is an empty state. And one more thing, temperature again became 0 here. If we substitute all these values in the above equation, this will be the result, 1 by E raised to plus infinity, because E raised to 9 minus 3, that means plus 6 minus plus 6 divided by 0. That means E raised to 1 divided by 0 is nothing but infinity. So positive infinity will become plus infinity. So if we add infinity plus 1, it will become 1 by infinity, nothing but 0. So that means we are at here and there is no electrons available above the Fermi energy level. So this is what they tried to explain in second case. So let us see third case. When the temperature is not equal to 0, temperature yavaga 0 ilde idda pakshadalli, that means some electrons will absorb the thermal energy. Some electrons will absorb the thermal energy and energy is equals to Fermi energy. Energy is equals to Fermi energy. If we substitute all these values in this equation, what is the result? As you can see, energy, when energy is equals to Fermi energy, that means E raised to 0 by kT. So 0 by something is nothing but 0. So that means E raised to 0 is nothing but 1. So by substituting all this equation, we got 1 by 2. That means we are somewhere around here. So here what happened? Some electron will absorb the thermal energy. Some electron will absorb the thermal energy and it will go to higher state energy level, and this energy state will be empty, and at the same time another electron will absorb some more energy and it will go to higher state energy level. Now before absorption the Fermi energy level is this much, after absorption the Fermi energy level is increased. So to show in the graphical representation, it will be like this. Some of the electrons are shifted above Fermi energy level. This is temperature dependence of Fermi factor, and this concept you may get it for 4 to 6 marks. Okay, so let us see the next concept, that is the important one, 8 to 10 marks derivation, expression for electrical conductivity. For this let us consider de Broglie hypothesis equation, that is lambda is equals to h by p. P is nothing but mass into velocity, and as we already know that lambda is nothing but 2 pi by k. The k is the wave number or wave vector. So by substituting equation number 1, we got mv into mv is equals to k by k into h by 2 pi. So differentiating this above equation, for differentiating this above equation, m is the mass of the electron, h is the Planck's constant, 2 pi is the number, so that means only v and k is the variable here. So due to that reason we can differentiate with respect to t. We get like this, m into dv by dt is equals to dk by dt into h by 2 pi. Let us take it as equation number 3, and here m into dv by dt is nothing but force applied. So due to that reason we can replace this equation with force. Now here we consider one conductor where there is not connected to external field or external electricity. So due to that reason the force is 0. Once is connected to battery, once this conductor is connected to battery, in that case force will be like minus e raised to e into capital E. That means the applied electric field in this direction, electron is moving in opposite direction. Due to that reason we have written minus E, charge of the electron, applied electric field, like this. Okay, and this is equals to F. So write down, by substituting here we get dk by dt into h by 2 pi equals to minus E, charge of the electron, electric field. Now dt will come this side and we write this equation like this, and integrating the above equation we get what we will get, and integrating the value, and the limit value is 0 to t. So take out the constant term in the above equation. As we can see here, h by 2 pi is the constant, minus E into capital E is the constant, dk and dt is the variable. So if we differentiate, we got this equation, k into t minus k into 0 equals to minus 2 pi by h into e raised e into capital E into t. Now simplify the above equation, as we are going to consider this Fermi sphere during the characteristic study or characteristic time. So Tf is the relaxation time or Fermi time. So as you can see, this is the Fermi sphere. Okay, so we are going to consider this in x-axis, y-axis and z-axis in the conductor. Okay, now we are applied the electric field in this direction. So in that case electron will move in this direction. So now we are going to compare this original place to this place. We take it as delta k. So before it's displacing, t is equals to 0. After it displacing, t is equals to t, which is we are shown here. So instead of writing this, we used to write like this, delta k is equals to minus 2 pi by h into E, capital E, t. So t is nothing but relaxation time. T is nothing but relaxation time. So replace normal T into tau. So the equation number 4 will become delta K equals to 2 minus 2 pi by h into capital E into tau. So let's consider equation number 2. What is that? mv is equals to kh by 2 pi. So as we can say, v and k are two variables, so that means m into delta v equals to delta k into h by 2 pi. We can write it like this. So rearranging the above equation, we get delta v is equals to delta k into h by 2 pi m. Take it as equation number 5. Take it as equation number 5 and compare this equation with equation number 4. Then we can get the ultimate equation is delta v is equals to minus E into capital E by m into tau. Now as I said, tau with respect to quantum free electron theory, tau is equals to lambda by Vf. Lambda is the mean free path, Vf is the Fermi velocity. So substituting in the above equation and rearranging the above equation, we get delta v is equals to minus Ef E into capital E by m into lambda by Vf. So delta v is nothing but drift velocity after applied electric field. So now considering the current density equation, by considering the current density equation which says J is equals to minus N E Vd. So this equation is going to substitute it here and we get J is equals to N E square E by m into lambda by Vf. So as we can see, J is equals to sigma into E. Substituting this equation in above equation, we can write J E is equals to, or we can write it like here, J E. So E get cancelled. The ultimate equation sigma is equals to N E square by m into lambda by Vf. This is the expression for electrical conductivity as per quantum mechanics. As per classical mechanics, the same equation will be like this: lambda sigma is equals to N E square by m into tau. This is the classical free electron theory equation for conductivity. Now, and this is the quantum free electron theory equation. Okay, and this equation or this derivation will be asked for 8 to 10 marks. Let us see the next concept we are going to cover, that is merits of the quantum free electron theory. So first one, according to specific heat. So as per specific heat, as you already know that what is the specific heat formula, Cv is equals to 2k by Fe into R into T. As per quantum free electron theory, as we already know that Fermi energy of any conducting material lies in between 1 to 10 electron volt. If we substitute in this equation, the result will be nearly equal to 10 raised to minus 4 into R into T. This result is almost equal to experimental value. As per classical mechanics, it is failed to explain it, as well as it is the experimental value is completely different for theoretical value. As per quantum free electron theory, it is accepted because experimental value and theoretical value almost all equal to each other. Due to this reason, specific heat of a solid comes under merit of a quantum free electron theory. So next one is temperature dependence of electrical conductivity. In this case, as we already know that what is the sigma? Sigma is nothing but N into E square by m into lambda by Vf. But in the case of classical free electron theory, sigma is equals to N E square by m into tau. Okay, so as you already know that lambda by Vf, lambda by Vf, where lambda is the temperature dependent quantity. Lambda is the temperature dependent quantity. That means if we increase the temperature, lambda is also have a relation. Lambda is inversely proportional to T. Okay, so as you can see here, lambda is inversely proportional to T. So as per classical free electron theory, lambda is also inversely proportional under root T, and the result which we compared for QFT, quantum free electron theory, and classical free electron theory, these two results with the experimental value, for CFT it doesn't holds good, or it doesn't near to the expected value, but for quantum free electron theory it always holds good, and this is very near to the expected value, which is proven by experimental result. Due to that reason, we can say temperature dependency also explained by quantum free electron theory. So let us see the last one, the electrical conductivity and electron concentration. As per classical free electron theory, sigma is n into e raised to 2 divided by m into tau, where sigma is directly proportional to n as per classical free electron theory. But in the case of quantum free electron theory, sigma is not only depends on n, it is also depends on lambda by Vf. This is the equation which we are getting because of quantum free electron theory. As per classical free electron theory, aluminium, zinc and cobalt must have, as per classical free electron theory, cobalt, zinc and aluminium act as a good conductor and the resistivity is very low as per classical free electron theory. But in the reality, we have copper, gold and silver. So these three things are very good conductor, where the outermost orbital has only one electron. But in the case of, as per classical free electron theory, if the outermost orbital, if they have divalent or trivalent, they are a good conductor. And once again here the experimental result doesn't hold good with classical free electron theory, but in the case of quantum free electron theory it holds good. Due to that reason, electrical conductivity also explained by quantum free electron theory. This is the end of the syllabus as per module number 4, quantum free electron theory. With this, I am going to finish this module, and if you like my video, please subscribe to my channel. Don't forget to share with your friends. And this is it. I am signing off. Thank you.